Hey y'all, let's look at solving some absolute value equations. Absolute value is the measurement of a number from zero on a number line. For example, absolute value of 3 is 3 because if you're at 0 on a number line and you go over to 3, you've moved 3 units. Absolute value of -5 would be 5 because if you start at 0 and you go to -5, you've moved a distance of 5 units. Carrying this notion forward, when you have an algebraic term like 2x minus 3 is equal to 17, if you think about 17 units away from 0 on a number line, you'll either be at -17 or +17. 2x minus 3 is what's being measured. So if you go 17 units left, 2x minus 3 is equal to -17. If you go 17 units to the right, then 2x minus 3 is equal to 17. Solving both of these equations for x, add 3, divide by 2, and you get x equals -7 for one of your answers. Add 3, divide by 2, and you get 10 for your other. Now later in the video, we will come back to these types of problems where instead of an equals, we'll have a greater than or a less than. But these are key numbers. These are values of x that make the statement true. Our example below, we have the absolute value of 5x plus 3 equals 13. Again, think of 13 as your distance from 0. If you go left 13 units, you stop at -13. 5x plus 3 is equal to -13. Subtract 3, divide by 5 when x equals -16 fifths. If you go 13 units to the right of 0 on a number line, you stop at 13. So 5x plus 3 can be 13. And that happens when you subtract 3, divide by 5 when x equals 2. So these are your two solutions to this absolute value equation. The only number that's 0 units from 0 on a number line is 0 itself. So if you have a distance of 0 units from 0, then there's only one equation to solve, and that's when 2x minus 3 is exactly at 0. You haven't moved any distance away. Add 3 to both sides, divide by 2, and this statement is true when x equals 3 halves. Keeping the notion of absolute value being distance from 0, again, back on the first slide, when we solved problems, we had a distance number of, say, 13. We went 13 units left, and that created a -13 as a location. We went 13 units to the right, and that made a +13. We're going to keep that same notion. X squared plus 6x, x squared plus 6x can either be at the negative of this or the positive of this, 3x plus 18. Inside the vertical bars doesn't change, but this distance notion on a number line can either be negative or remain positive. On the left equation, let's distribute the negative, -3x minus 18. Because we have a quadratic term, I'm going to add 3 x's to both sides. I want to get everything on one side. So the process of zeroing out the right side, I'm going to add 3 x's. That'll make a 9x. And then I'm going to add 18. That gives us x squared plus 9x plus 18 equals 0. Once you've got that zeroed out, this will actually factor with a 6 and 3. The sum of 6 and 3 is 9. The product is 18. Set each factor equal to 0, and you will find x equals -6 and -3. In the other equation to your right, we leave 3x plus 18 positive. We don't negate it this time, so we leave it as is. Moving everything to the x squared side, we subtract 3 x's from both sides. That leaves x squared plus 3x equals 18. To move 18 over, we subtract it. There's no constant over here to subtract 18 from, so that just creates x squared plus 3x minus 18. Now we've got it equal to 0. X minus 3x plus 6 will factor this trinomial. Negative 3 plus 6 is 3. Negative 3 times 6 is negative 18. Set each factor equal to 0. You get 3 and negative 6. Negative 6 showed up twice, but you only need to report it once. The other two solutions, there are 3 total. The other two are negative 3 and positive 3. Now we're going to switch to solving absolute value inequalities. Let's remember that distance from 0 is what we're really looking at when we talk about absolute value. In this top example, on the first slide, this was an equal sign, but I'm going to change it to a less than or equal to. When your distance from 0, and again, that's what absolute value measures, when this distance is less than or equal to 17 units from 0, you can only go left 17 units, and you can only go right 17 units. Anywhere in between is okay. So the way you kind of interpret this part is you stay within 17 units of 0. Well, how do we do that? We take 2x minus 3 and we trap it between negative and positive 17. That's over here in the red ink. That forces us to solve a compound inequality, add 3 all the way through. Negative 17 plus 3 is negative 14. That leaves us 2x in the middle. Those 3's cancel. 17 plus 3 is 20 on the right. And then to get x totally solved in the middle, we divide off the 2 everywhere. That leaves us with negative 7, x, and 10. Remember from the very first example, and if you have to rewind, that's okay too, these were our key numbers, and those were the only 2 solutions, negative 7 and 10. But with an inequality, because we are trapped with a distance no more than 17, we have to include all the numbers between the key numbers. So any number from negative 7 to 10, including those 2 numbers, will satisfy this problem. You're looking at an interval of numbers. Now, the example on the bottom, the first time through, we solved it as an equation. We got answers of negative 16/5 and 2. When your absolute value is greater than a number, that means you have to keep a distance farther from 0 than, in this problem, 13 units. Well, if you start at 0 and you go 13 units, you stop at negative 13. But since our distance has to be 13 or more units away, we stay left of negative 13 on a number line. That's where this first inequality comes from. 5x plus 3 less than or equal to negative 13. That ensures that we're staying a distance farther than 13 units from 0. If you go right on a number line and you go out to 13 units, if you stay farther than that on a number line, you're going to be greater than or equal to 13. 5x plus 3 is less than or equal to negative 13. Subtract 3 from both sides. Divide both sides by 5. And one interval of numbers are values of x that are less than or equal to negative 16/5. If we plot that and we stay less than or equal to, we use a bracket and shade left. In the other inequality, 5x plus 3 is greater than or equal to 13. We subtract 3. 5x is greater than or equal to 10. Divide both sides by 5. And the other interval of numbers that satisfies our statement in the very beginning are values of x 2 or larger. And that would be this right shaded area. All right, so let's look at some fresh examples. The previous two examples were based on the first two examples where we just traded out an equal sign for an inequality. In this example, we have the absolute value of x over 2 less than 3. So x over 2 can only travel a maximum distance of 3 units right or left of 0 on a number line. If you go left 3, you have to stop at negative 3. If you go right 3, you have to stop at positive 3. A distance of less than 3 units puts you somewhere between negative 3 and positive 3 on a number line. So that's why we take x over 2 and we trap it between those two numbers. Notice that this time the inequalities are not underlined. It's still a compound inequality, so if you multiply all the way through by 2, that leaves us with negative 6 less than x less than positive 6. It's actually easier to just say all my answers are trapped between negative 6 and positive 6. Since the inequalities are not underlined, we use parentheses at the key numbers, and our interval of x values that work are between negative and positive 6. So just remember, less than forces a compound inequality because you have to stay trapped. You can't go more than a certain distance from 0. Our last example, we have the absolute value of 1 minus 2x greater than 5. This means if you sketch a number line marked 0, you have to stay more than 5 units away from 0. Well, that means you have to be left of negative 5 or right of positive 5. Numbers like 6, 7, 8, or negative 6, negative 7, negative 8, those are more than 5 units away from 0 on a number line. 1 minus 2x less than negative 5. Let's solve for x. Subtract 1. Negative 5 minus 1 is negative 6. Don't forget that negative here. When you divide by negative 2, you've got to reverse your inequality symbol. So x is greater than positive 3. That's this shaded area. The other inequality, 1 minus 2x, being greater than 5, we subtract 1, negative 2x greater than 4. Again, to solve for x, we're going to divide by negative 2. When you divide by a negative, turn your inequality around, x less than negative 2. And that's all values of x to the left of negative 2 on a number line. This left interval is made up of values of x from negative infinity to negative 2. Then we have a jump, and we have more x values at 3 or farther to the right, 3 to infinity. Again, don't use brackets if the inequality is not underlined.